Right, Bismillahirrahmanirrahim. Assalamualaikum. So, let's look at theorem number 4. Let Z be a standard normal random variable, and let W be chi-squared distribution. So it says that Z is having a standard normal distribution, and W is having a chi-squared distribution with V degree of freedom. So this is theorem number 4. So then we can say that Z, when Z and W are independent, so it's going to have a T distribution where Z divided by square root of W over V. Right, so means that this is a standard normal distribution divided by the square root of a chi-squared over degree of freedom, V degree of freedom. So it's going to have a T distribution with V degree of freedom. Right? T distribution with V degree of freedom. Nampak macam W kan bukan? This is a V degree of freedom. Alright. So this is theorem number 4. So let's look at some derivation for theorem number 4. So let's say we know that T is having Z over square root of W over V. So we know that Z is a standard normal distribution. So X bar minus mu divided by sigma over square root of N. Right? And based on theorem number 3, right, n minus 1 s squared over sigma squared is having a chi-squared over chi-squared n over n minus 1 degree of freedom. So let's say we try to replace dekat sini n minus 1 as a v. This one kita mana pun boleh. Kita let's say this is v. So kita note n minus 1 is a v, a degree of freedom, s squared over square root of sigma over sigma squared over n minus 1. So this is v jugalah, benda yang sama kan. So let's say kita note dekat sini, note based on theorem number 3, note v is equal to n minus 1. Right. So dekat sini, let's say kita bawa dekat atas kan, let's say this one kita letak square root of n x bar minus mu divided by sigma, right? And then this one, this is square root kan, so based on this formula, right? So n minus 1 ni letak ke atas sekali, so this one should be square root of n minus 1, right? So this one I bawa ke atas kan, so this one sigma, and yang ni this one should be square root of n minus 1 s square over sigma square. Right? Number I simplify from this formula to this, right? So kalau you tengok dekat sini, this one we can remove this one and this one, boleh padam kan, and this one boleh cut off, right? So what left is x bar minus mu multiply with square root of n divided by square root of s square, right? So let's simplify this one. So s bar minus mu divided by S over square root of n. So this is t distribution, right? So this lead to theorem number 5, which is when you have a t distribution, right? So and then x bar and s square are mean and standard and variance for random variable and sample size n, and from a normal population with mean equal to mu and variance equal to sigma square, then the t distribution, the formula for t distribution is x bar minus mu divided by s over square root of n. So remember, kalau z distribution, right, x bar minus mu divided by sigma over square root of n. So this is a for sampling distribution, right? So for simple random variable, right, x minus mu divided by sigma, right? Remember, if this is a standard normal distribution, when you have a t distribution, so t will be equal to x bar minus mu divided by s over square root of n. So in t distribution, so it says that when you have this formula x bar minus mu over s over square root of n, it says that t distribution with n minus 1 degree of freedom lah. So because we are deriving from theorem number 3, right? Theorem number 3 says that chi-squared with n minus 1 degree of freedom. Okay, so this is theorem number 5. So when to use t distribution and when to use z distribution? So it based on the known and unknown variance lah. Let's say variance. So this is a common this is a standard what we call rule. If you look at in most of the statistical books, it will says that when you have population variance can be divided into two parts. When the population variance is known in a given statement, and another one is population variance is unknown. Right? If the population variance is known, we're going to use Z distribution, right? Z distribution, no matter how large or small the sample size, right? For n is less than 30 or n is more than 30 when the sample population variance is known. When the population variance is unknown, we need to look the consideration of sample size when n is less than 30 and n is more than 30. When n is less than 30, we're going to use t distribution, and more than 30 we use z distribution. Right, so this is a simple chart to differentiate when to use t and z distribution lah. Okay, so before we proceed further, the t distribution came from a z distribution, right? So it's having a standard normal, it's come from a standard normal distribution. So t distribution is also look like a normal distribution juga lah. It's having a bell-shaped curve with mean equal to 0, and from negative infinity to infinity. The concept, the characteristic on the left hand area on the left hand side is equal to area to the right hand side juga lah, benda yang sama. So let's say we want to find the area on the left hand side. Let's say this is 0.025. We want to know. So the cut point here, right? This cut point or this point would indicate t 0.025 with degree of freedom. Right, so we need to read with the degree of freedom. Okay. Alright, let's look at example number 5. In example number 5, in 16 1-hour test run, right, the gasoline consumption of an engine averaged 16.4 gallons with a standard deviation of 2.1 gallons, right? Test the claim that the average gasoline consumption of this engine is 12.2 gallons per hour, right? So now we have n equal to 16, right? Is it? Sebab dia kata dekat sini in 16 1-hour test run, n equal to 16, and the average is 16.4. So this is the average from 16 test lah. X bar equal to 16.4, right? So a standard deviation is 2.1 gallons. So this standard deviation is from 16 juga kan, S square. So this is a standard deviation, just S, right? Just S equal to 2.1, right? So dia bukan population standard deviation, right? So we want to test the claim that the average gasoline consumption of this engine is 12.0. So our population mean is 12.0 lah. So now since we already have this information, so the T distribution is equal to X bar minus mu based on theorem number 5, S over square root of N. So this one should be 16.4 minus 12 divided by 2.1 over square root of 16. Right, so this one should be lead to 8.38 lah. Okay. So this is how we calculate T distribution, okay? So we can test the claim. This is an example of question for hypothesis testing lah. Tapi in this topic, I just want to show you until T distribution saja. So how we going to calculate T distribution. To solve this problem, we will look into the next chapter lah. Right, now let's look at example number 6. Right, in example number 6, tensile strength for type of wire is normally distributed, right, with unknown mean. So we don't know the mean, population mean, and unknown the population variance. And it took 6 pieces of wire randomly selected from a large roll yi. So we have n equal to 6 lah. So tensile strength portion is measured from 1 until 6 lah, okay. The population mean and variance can be estimated by y bar, right, and s square respectively. So dia kata dekat sini sigma y bar squared is equal to sigma over n. This is from a sampling distribution lah, right? So it is also can be followed by S square over N based on sampling distribution. So we need to approximate y bar from be within 25. It's not 25 actually. Soalan dia this is I salah tulis 2s over square root of n. It's not 25, okay. Right. So apa yang kita nak kat sini, this is the equation, the thing that question ni nak lah. we want to estimate y bar from the true population mean within 2s over square root of n. So this one should be within y bar minus mu. So between y bar and true mean, right? So this one is 2s over square root of n, and this one should be negative 2s over square root of n. Okay, so remember theorem number 5 says that x bar minus mu divided by s over square root of n. So dekat sini, let's say we want to convert this to t distribution. So why we convert this to t distribution? Because we only have n. The population variance is unknown, right? Dia kata dekat sini, the population variance is unknown, and we only have a small sample size, right? Less than 30. So we're going to use t distribution. So let's convert this to t distribution. So y bar minus mu, we just impose another parameter, which is s over square root of n, right? Another one is negative 2s over square root of n. So divide by s over square root of n. Another one is 2s over square root of n divided by s over square root of n. Nampak tak? Kita just impose the denominator dekat semua tempat, kan? So dekat sini, it should be equal to p negative 2. Kita boleh cancel this out and this out, kan? Boleh nampak, eh? So this is t2, right? So we want to estimate this value. So let's draw the distribution curve, right? So this is 0, this is negative 2 and 2. So we want to find this area, right? So this one, what is this area? Kita boleh tengok dalam statistical table. Sekejap kita buka. But we need to know the degree of freedom. What is the degree of freedom? Degree of freedom for t distribution is n minus 1 based on theorem number 5. So n minus 1 equal to 5 lah. Right, so 5. So kita tengok theorem statistical table. Wait So statistical table, we're going to look at table t distribution. T distribution is table number 7. Right, muka surat 16. Right. So dekat sini, basically we don't know the value of alpha, right? We don't know the value of alpha, right? So we want to estimate the alpha. We want to find the alpha value. So dekat sini kita nak tengok this t. You kena faham the table ni dia bagi tak sama macam normal distribution. So the table give the value of t alpha and with v degree of freedom, right? So dekat sini dia kata with v degree of freedom. So this value represent t alpha with v. V is a degree of freedom lah. So the tabulation for one tail only, so dia akan bagi one tail only on the right hand side, means that for the positive side lah. right? So the absolute T, the column heading for alpha must be double lah, means that dia sama konsep dengan standard normal distribution. So on the right hand side sama dengan left hand side. So dekat sini this is alpha, and normally we want to find this value, right? But we already know this value is equal to 2, and based on our example we already know this is equal to 2, right? So kita kena cari dalam ni the value inside here equal to 2 or nearest to 2. So yang paling dekat dengan 2 ataupun sama dengan 2. So kita tengok dekat sini dekat dengan 2 atau sama dengan 2 adalah inilah, is 2 dekat bawah. Tapi but we need to consider our degree of freedom. So our degree of freedom here is 5, right? So kita tak boleh simply ambil dekat sini because degree of freedom here is 60. So we need to look at 5 V degree of freedom. So 5 degree of freedom paling dekat dengan 2 sama ada ini ataupun ini, right? So the nearest is to be here lah, 2.015. So the alpha here is 0.05. Okay? So we can replace here, this one should be dekat sini, this is the area 0.05, and we know on the left hand side pun should be equal to 0.05. So this one probability of this area should be 0.90 lah, right? Because this is 0.05, 0.05, so 0.05 plus 0.05 is equal to 0.10. The complement of 0.10 is 0.90 lah. Okay? So now let's look at theorem number 6. Ada soalan tak setakat ni? Theorem number 6 says that if U and V are independent random variable, right, with having a chi-square distribution. So U and V is having a chi-square distribution with V1 and V2 degree of freedom respectively. So we know here U is having a chi-square degree of freedom with V1. V is having a chi-square degree of freedom with V2 degree of freedom. Sorry, apa yang sebut? U is having a chi-squared with V1 degree of freedom. V is having a chi-squared with V2 degree of freedom. So if we take the fraction of U and V, right? So you're going to have F distribution with V1 degree of freedom and V2 degree of freedom, right? So this is the PDF for F distribution where it's integrate two random variable U and V, right? Remember, this is part of chi-square distribution multiply with divide by chi-square distribution. So this is theorem number 6. And theorem number 6 can be extend to theorem number 7. Oops. Right, kita tengok theorem number 7 is extension of theorem number 6. Benda yang sama, right? If S1 square and S2 square are variance, sample variance, right, from n1 with sample size n1 and n2 from a normal population with variance equal to sigma 1 squared and sigma 2 squared. So dekat sini, if you notice, look at theorem number 3. Theorem number 3 benda yang sama kan? N minus 1 S squared divided by sigma 2. Right, it's having a N minus 1 degree of freedom. So it derived, theorem number 7 is derived from theorem number 3. Right, theorem number 3 divided by, the N, N minus 1 S squared over sigma squared. This is having a chi squared with N minus 1 degree of freedom. So kalau kita divide benda yang sama, N minus 1 S2 sigma squared, so you can derive yang inilah, right? So provided N minus 1 benda yang sama lah. Okay, so it says that theorem number 7 says that S1 squared divided by sigma 1 squared can be manipulated to get this final formula, which is sigma 2 squared multiplied with S1 squared divided by sigma 1 squared multiplied with S2 squared. Right, so both is having F distribution with V1 and V2 degree of freedom, and V1 should have N1 minus 1, V2 is N2 minus 1, because this is derived from theorem number 3, right? Theorem number 3, N minus 1 degree of freedom, right? Oh, so dia tulis kat bawah ni dah, nampak dah, right? So this is the formula. So now let's look at example number 7. So example number 7, if we take independent sample of size n1 equal to 6 and n2 equal to 10 from two normal population with equal population variance, maksudnya the sigma 1 squared is equal to sigma 2 squared. So this is the mean of equal population variance. So we want to find B such that probability of S1 squared divided by S2 squared less than B equal to 0.95. Okay, so from here we know N1 equal to 6, N2 equal to 10, right? And sigma 1 squared equal to sigma 2 squared. So let's say sigma 2 squared S1 squared divided by sigma 1 squared S2 squared is having a F distribution with V1 and V2 degree of freedom. This is based on theorem number 7, right? So let's say sigma 1 squared and sigma 2 squared is equal, so it should lead to S1 squared to divided by S2 squared only, right? So it's having a F distribution, kan? So we know V1 is 6 minus 1, which is equal to 5. V2 is equal to 10 minus 1 equal to 9. So this is the degree of freedom for V1 and V2, right? So since we want to find the area on to the right, to the left, okay, so F distribution, since F distribution is derived from 2 chi-square distribution, So the distribution should look like a chi-square distribution as well lah. So you should have a skew to the right distribution punya curve, right? So um, this is the this is not the area that we want to find. This is the area that we want to find, less than B 0.95, and this is B, right? And this B should represent F alpha V1 and V2, right? V1 and V2. So we have 2 degree of freedom. So kita tengok dalam statistical table. Is my statistical table. F distribution should be, this is a chi-square, table number 8. Table number 9 is F distribution. So before we use the statistical table, always read the instruction, right? Sebab different statistical table, different method of reading the value. So dekat sini dia kata table give value F alpha V1 and V2. Right, sama konsep yang kita nak, V1 and V2. Alpha V1 V2. Right. So you should be very careful lah which one is V1 and V2 bila you tengok different statistical table. Right, dekat sini for each pair of V1 and V2, right, alpha is 0.05, 0.025, 0.01, 0.001, and 0.025 value is being bracket. So dekat sini, kalau you boleh nampak, let's say I make it bigger. Dekat sini, dia kata, this first value, right, this first value is representing alpha 0.05. The second value here with bracket, right, this one is representing 0.025, right, because dia kata 0.05 value is bracket lah. And then the next one is 0.01, 0.001. Right, ada yang bawah lagi? Atau dah ini je lah, 4 value saja kan dia bagi. So this is the value yang dia bagi, 4 value saja. Right. So now let's say you want to find the area to the right, right? So dia bagi dekat you the value to the right, kan? To the right. Right. So dia tak bagi value to the left. So dekat sini, since we want to find the area to the left, so the area to the right is should be equal to 0.05, right? So this one, probability of S1 squared over S2 squared less than B equal to 0.95. So it should be equal to the 1 minus the complement, right? We want to find the complement, probability of S1 squared over S2 squared more than B equal to 0.05. Right? So 0.05, because sini kita boleh tengok the degree of freedom. V1 is equal to 5 and V2 is equal to 9. V2 equal to 9 and 5. So dekat sini the area that we want to find, and since alpha 0.05, so it should be 3.48 lah. 3.48. So B should be equal to 3.48. Okay? Boleh, eh? So now let's look at example number 8. example number 8 says that suppose that x is having a standard normal distribution and y is having a chi-square distribution with 2 degree of freedom. So kita nak tulis so kita lupa. So let's say x is having a standard normal distribution and y is having a chi-square distribution with 2 degree of freedom. And we want to state the distribution and its appropriate parameter for each the following random variable. So the first one, let's say r equal to x over square root of 3. Right? Boleh nampak kan? Kita kena besarkan sikit. R equal to x divided by square root of 3. So we know from here x is having a standard normal distribution, right, and y is having a chi-squared with 2 degree of freedom lah. So first we need to find the expected of r. Expected of r should be expected of x over square root of 3. So this one should be 1 over square root of 3 expected of x. Expected of x should be equal to 0. So this one should be equal to 0 lah. Expected of r is equal to 0. And then variance of r should be variance x over square root of 3. So we take out this one, 1 over 3 variance of r equal to 1 over 3. Variance of r is equal to 1, right? So we can say that r is having a normal distribution with mean equal to 0 and variance equal to 1 over 3. This is for number 1, right? For number 2, b is s equal to x square. This is not a chi-square kan? Dia kata dekat sini x square, right? X square based on this statement, x square plus y. So number 2, it says that s equal to x square plus y. So this one should be standard normal distribution, right? And then you square plus a chi-square distribution with 2 degree of freedom. So remember theorem number 2 says that theorem number 2, where is theorem number 2? Is it theorem number 2 or theorem number 1? Theorem number 2. Right, theorem number 2 kita dah belajar sebelum ni. When we square the standard normal, right? When we square the standard normal, we're going to have a chi-squared with 1 degree of freedom. Right? When we square standard normal, we're going to have a chi-squared with 1 degree of freedom. And when we make a summation of the chi-squared, we should have the summation of the chi-squared lah. And the degree of freedom n tu the degree of freedom should be it should be in additive form lah. Right? Maksudnya kita boleh tambah degree of freedom. So this one should be a chi-squared with 1 degree of freedom plus a chi-squared with 2 degree of freedom. So we should having a chi-squared with 3 degree of freedom. So we can say that S is having a chi-squared with 3 degree of freedom. Remember theorem number 2, okay? So number 3 we have t is equal to 3 divided by s and squared multiply with this is not square, this is 1 over 2, maksudnya square root lah, multiply with square root of 3 multiply with r as defined in part 1 and part 2. So number 3 says that 3 over s, and then we have a 1 over 2 here, and square root of 3 multiplied with r. Square root of 3 multiplied with r. Okay, and we know from here, jangan confuse, we know from here r is having a normal distribution with mean equal to 0 and variance equal to 1 over 3. And S is having a chi-squared with 3 degree of freedom. Okay. Alright. How to solve this one? So this one is also equal to square root of 3 divided by square root of s multiply with square root of 3 multiply with r. Right. So let's try to solve part by part lah. So this is the first part and this is the second part. So now let's look at square root of 3r. Right, square root of 3r. So let's find the expected of square root of 3r. So it should be square root of 3 expected of r should be equal to 0. Right, because expected of r is equal to 0. And then variance of square root of 3r should be 3 variance of r equal to 3 multiplied with 1 over 3 equal to 1. So we can see that square root of 3r is having a standard normal distribution. So we can just plug in the value here. Should be square root of 3 multiplied with standard normal distribution and divide by square root of s is a chi-squared with 3 degree of freedom. Kan? So kalau kita expand, right? We try to expand, make it look like in theorem number 6, right? I think theorem number 5. No, theorem number 4. Kita tengok theorem number 4 lah, senang kita nak ni kan. So this one should be standard normal distribution, a chi-squared with 3 degree of freedom divided by 3. So it's having a t distribution with 3 degree of freedom. Betul? Kita compare to theorem number 5. Sorry, theorem number 4. Kan? So next is u is equal to 3y divided by 3s. Alright? Number 4. Right. Number 4, u is equal to 3y divided by 3s. 3y and 2s. Okay. 3y and 2s, and we know s, y and 2 is defined previously. So s is having s is having a chi-squared with 3 degree of freedom, chi-squared with 3 degree of freedom, and y is having a chi-squared with 2 degree of freedom. Is it? Y is having chi-squared with 2 degree of freedom. So this one should be 3 chi-squared with 2 degree of freedom, 2 chi-squared with 3 degree of freedom. So kalau kita expand, make it look like as in theorem number 6, right? Kita nak bagi dia nampak macam theorem number 6. So it should be a chi-squared with 2 degree of freedom divided by 2, a chi-squared with 3 degree of freedom divided by 3. So this is having a F distribution with 2 degree of freedom and 3 degree of freedom. Right? Okay, so let's look at B. Dekat sini B dia kata apa? A random sample size of 100 is taken from a normal population with sigma equal to 25. So what is the probability that sample mean will be within 3 of the true mean? So benda yang sama tadi. So sekejap lupa dia punya sample size is equal to 100 and population variance equal to standard deviation equal to 25. So population standard deviation is equal to 25 and equal to 100. So remember the chart I gave to you earlier, right? Chart yang I tulis tadi, mana dah? This chart, right? So population variance known, terus pakai Z distribution, no matter how large or how small the sample size, right? So we're going to use Z distribution lah, right? So dekat sini dia kata find the what is the probability that sample mean will be within 3 of the true mean. So probability of negative 3 x bar minus mu 3 lah, right? So we're going to use Z distribution, right? So this one should be probability of negative 3 over square root of sigma over square root of n lah, right? So remember Z equal to x bar minus mu over sigma over square root of n, right? So this is Z distribution, 3 over sigma over square root of n. So this one should be P negative 3 25 over 10, right? This is Z 3 25 over 10. So this one should be 1.2, right? Can you calculate? Three divided by 2.5 is equal to 1.2. So this one should be probability of negative 1.2 Z 1.2. So it should be equal to 1 minus 2 PZ more than 1.2 lah. So this one should be 1 minus 2 1.2. Tengok balik statistical table. 1.2 should be 1.2 should be 1.5. Sorry, 1.2 here lah. 1.2 is 0.1151 lah. 0.1151. So this one should be berapa? You kena kira lah. 0.1151 multiply with 2, 1 minus al. This one should be 0.7698. Okay. Right. So now let's look at example number 9. Benda yang sama lah, right? So the question should be look like this lah. Okay, so let's look at example number 9. And then example number 10, 11, 12, 13 And 14 you can do by yourself lah, but better I will show you 14 as well. Tapi yang lain-lain you boleh buat sendiri lah. I leave it for you to do by yourself. So let's look at example number 9. Example number 9 says that suppose that y1 until yn be a random sample of size n taken from a normal distribution with mean equal to mu and unknown variance sigma as theta. Right, state the distribution and parameter of the following variables. Right, so now let's look at the first one. So number 1, R is having, dia tak beritahu apa-apa, so dia beritahu yi is having a normal distribution with mean equal to mu and variance equal to theta. That's all. So R is equal to y1 plus y2 minus y3 plus y4. Right, so first we need to find the expected of R. Expected of R is equal to expected of y1 plus y2. Actually boleh buat benda yang sama lah, y3 plus y4. Right, so this one should be expected of y1 plus expected of y2 minus expected of y3 minus expected of y4. Right, so this one should be mu plus mu minus mu should be equal to 0. Right, so variance of R, so variance y1 plus y2 minus y3 plus y4. Right, so this one should be variance of pecah kepada dua part kan. So y1 plus y2 plus variance y3 plus y4. So notice I convert the sign. So this one should be variance of y1 plus variance y2 plus variance y3 plus variance y4. So this one theta plus theta plus theta plus theta equal to 4 theta. So we can say that R is having a normal distribution with mean equal to 0 and variance equal to 4 theta. Okay. So next question is number 2. S is equal to R divided by 2 over square root of theta. R divided by 2 square root of theta, where R is defined from part 1. So simple juga benda yang sama. So we know that R is equal to normal distribution with mean equal to 0 and variance equal to 4 theta. So expected of S is equal to expected of R over 2 over square root of theta. So this one is 1 over 2 square root of theta multiply with 0. So this is equal to 0 lah. So variance of S is equal to variance R over 2 square root of theta. So it should be 1 over 4 theta, right, multiply with variance of R is equal to 4 theta is equal to 1. So we can say that S is having a standard normal distribution lah. Okay. And number three says that v is equal to square root summation of y minus mu square. So v is equal to summation of y yi, right? Y minus, this is yi lah, minus mu squared when I equal to 1 until n, right? So yi is from a standard normal distribution kan, from normal distribution. Y is a normal distribution. So kalau kita tengok dekat sini, let's say we compare it to theorem number 3, I think. Theorem number 3 or theorem number 2. Let's look at theorem number 3 first. Yeah. Theorem number 3. But in theorem number 3, we don't have the value of mu. Right? The value of mu don't have. Let's look at theorem number 2. So in theorem number 2, we have xi minus mu divided by sigma square, right? Is having a chi-square with 1 degree of freedom, right? It's having a chi-square with 1 degree of freedom. So remember Z distribution. Z is having x minus mu divided by sigma. So Z square x minus mu divided by sigma, and then squared everything, is having a chi-squared with 1 degree of freedom. Kan? So ada kat sini kan. So theorem number 2 also says that when you trying to take a summation of zi, where I equal to 1 until n, is equal to summation of xi minus mu divided by sigma, and then this is a square root, right? I equal to 1 until n. This is having a chi-squared with n degree of freedom. Kan? So dekat sini kalau kita convertkan summation of yi minus mu and assume theta is equal to 1. If you assume theta is equal to 1, so this is having a chi-squared with n degree of freedom, right? So we can say that v is having a chi-squared chi-squared with n degree of freedom if theta equal to 1, right? So if theta equal to some others value, kita takkan dapat macam ni lah, right? So we try to convert based on our knowledge saja kan, based on theorem number 2, right? So let's look at number 4. Number 4 says that y equal to square root of n multiplied with s divided by square root of v, right? So this is t equal to square root of n s over square root of v, where s is having standard normal distribution, with mean equal to 0 and variance equal to 1. And V is having a chi-square distribution with n degree of freedom. Right? Boleh? So this one kita boleh letak macam ni lah. As a square root of n01, right? Right. This is a standard normal distribution, and V is a chi-squared with n degree of freedom. So we compare with theorem number 4, right? So this one should be a chi-squared with n degree of freedom is having a t distribution with n degree of freedom. Okay, simple kan? Senang saja kan soalannya, tak susah pun. So V pula ni, this is number 5. Number 5 says that P is equal to T squared. P is equal to T squared. So we want to find P equal to T squared. So this one should be, T is defined as this one lah, T or with degree of n degree of freedom kan. So n 1, right? So this one, this is standard normal distribution, right? Divided by square root of chi-squared n with n degree of freedom, and then we square this one, right? So this one should be standard normal distribution square over chi-squared with n degree of freedom. So we know from theorem number 2, this one should be a chi-squared with 1 degree of freedom. So this one should be chi-squared 1 degree of freedom, right? So 1 divided by 1 tak tunjuk, tak apa. This is a chi-squared n degree of freedom. So this one should be f with 1 and n degree of freedom. Okay? Alright, so let's look at example number 9, continue B, right? This is B, So can or salmon are supposed to have a net weight of 6 ounce, right? So this is the average weight lah. Weight is 6 ounce, right? The canner says that the net weight is a random variable with mean equal to the population mean is equal to 6.05 ounce and standard deviation sigma equal to 0.18 ounce. So suppose that you take a random sample of 36 can and calculate the sample mean weight to be 5.97 ounce, right? Find the probability that the mean weight of the sample less than or equal to 5.97 ounce lah. So based on the information, we know that n equal to 36 and we have the population standard deviation equal to 0.18 and population mean is equal to 6.05. So based on the first two information here, the population variance of standard deviation is known. So straight away kita akan pakai Z distribution lah, right? So what we want to find is the population x bar, find the probability of mean weight. Mean weight x bar is less than or equal to, right? Equal to 5.97, right? So this one straight conversion lah. Z x bar 5.97 minus 6.05 divided by 0.18 over 36. Correct. So this one should be probability of Z less than Less than or equal doesn't matter because this is a continuous, kan? 5.97 minus 6.05 divide by 0.16 over 6 is negative 2.67. Negative 2.67. Right. So draw a distribution curve. This is 0. Negative 2.67 should be here lah. So we want to find this alpha. Boleh juga convert. Is also equal to probability of Z more than 2.67, right? Benda yang sama. So we look at the statistical table. 2.67 should be here. Is 0.00379. So 0.00379. Right? Okay? So example number 10, I think you can do it by yourself, right? So it's the same procedure, right? So you want me to show or you want to do it by yourself? You do it by yourself, right? Okay, you do it by yourself. Example number 11, I think you can... This one I already shown before, kan? Previously I dah shown dengan you. Tapi this one different value saja, kan? Sebenarnya sama, you can do it by yourself. Example number 12. So I will show you example number 12. So suppose that x1 until x20. Alright, so we have two sample here, x1 and x and y lah. Y we have 25, x we have, this is nx, we have 20, and y we have 25. So x is having a normal distribution with mu1 and variance equal 125. Y is having a normal distribution mu2 and variance equal to 200. So determine the sampling distribution y bar x bar minus y bar. So first we need to find the expected of x bar minus y bar lah. So this one should be x bar minus expected of y bar. So this one should be 1 over n expected of summation of x, right? Remember x bar equal to summation of x over n. Y bar is also same, right? Y over n. Okay, so this one also same lah. This is n1, n2. Okay, so expected of summation of y, yi lah, xi. So daripada sini kita boleh work out kan dia punya solution, right? Because we already know the expected of y bar, yi. So this one should be 1 over n, n1. So n1 mu 1. Right? So this one should be mu 1 only, kan? So this one sama jugalah, n2 mu 2. So this one mu 1 minus mu 2. Right. So the second part is a variance of x bar minus y bar. Right. So this one should be variance of x bar plus variance of y bar. So this one should be 1 over n1 squared and n1 125. Okay. Okay, kejap. So this one plus n1, n2, n2 squared, right? N2 squared, n2, and then this one should be 200. Okay, so we can take off this one. So this one should be 125 over n1 plus 200 over n2. So this one should be 125 over x. X is we have 20 kan. First one n1 is 20 plus 200 over 25. So this one should be 57 over 4 equal to 14.25. So we can say that x bar minus y bar is having a normal distribution with mu1 minus mu2 and 57.4 lah. Okay. This is one way. We can also solve it by using a moment generating function. So if you want to solve it by using moment generating function, benda yang sama jugalah. So M, saya guna color lain lah. Mx bar minus y bar, right? So this one should be expected of exponential t x bar minus y bar. So we need to know the MGF for x, right? MGF for x is equal to expected exponential mu t plus 1 over 2 t squared sigma squared. My t should be sama jugalah. So it came from normal distribution kan. So this one should be divided by n1 and n2, right? So you multiply lah benda yang sama. Expected of ETX bar plus, so this is this is for x kan. Let's say kalau kita nak cari x bar, dia divide by 2, dia ada macam ni. Okay, this is for x bar. This is for a single value and this is for x bar. Right, divide by sigma divide by n2, n1 lah, n2 ke, tak kisahlah. Right, so multiply with expected of exponential ty bar. So this one should be exponential mu t, this is a mu1 for x bar. X bar is mu1 plus 1 over 2 t squared sigma 1 squared over n1. This is the first part. Multiply with the second part, exponential mu 2t plus t, plus 1 over 2 t squared sigma squared over n2. So kalau kita this is plus, right? This is plus, this is T. Okay, so kita pecahkan ini dengan ini untuk satu tempat, ini dengan ini satu tempat lah. Boleh faham tak? So what I want to do now is I want to make it this one in one part and this one in second part lah. So this one should be exponential mu1 minus mu2, right? Wait. This is minus dekat sini, right? So it should be negative dekat sini, right? Dia bukan kali macam tu saja, bisa negatif dekat sini. So this one should be negative here, negative mu2, right? So that's why mu1 minus mu2 t, right? And then kita combine dulu lah, combine dulu senang. Kalau tak, susah kita nak pecahkan. Say mu1 minus mu2 t, right? Kita combine this one and then plus 1 over 2t squared. Kita boleh combine dua lah, 1 over 2 t squared and then multiply with sigma 1 squared over n1 plus sigma 2 squared over n2. So bila you simplify kan, dia akan dapat macam tu lah. Bila ditambah dua ni kan, ini nampak this part and this part kita tambah kan. So we take out 1 over 2t outside kan. So tambah macam tu. Alright. So now we just plug in the value lah. Plug in the value. So exponential mu1 minus mu2 t 1 over 2 t squared, and then this one should be 125 over 20 plus 200 divided by 25, right? So mu1 minus mu2 t plus 1 over 2 t squared. This is 57 over 4 lah. Right, so we can say that this is having a normal distribution with mean equal to mu1 minus mu2 and variance equal to 57 over 4. Dan yang sama lah. Okay. So example number 13. I think example number 13 you can do by yourself. So dia kata kat sini let x be a random variable from a chi-square distribution with 4 degree of freedom. So we just write down the PDF. Show the expected value is equal to 4. Senang je kan? Right? Just plug in the value of this is the PDF of chi-squared fx. Remember chi-squared it came from a gamma distribution, so 1 over gamma alpha, right? Gamma alpha beta alpha, right? X alpha minus 1 exponential negative kita ingatlah negative alpha divided by negative apa tu? Negative x divided by beta, right? Betul? Can you check? You need to remember this one. X divided by beta, right? X is more than 0. Beta is also more than 0. Alpha is also more than 0. This is gamma distribution, kan? Gamma PDF. Can you check? Najwa Aminuddin, Can you confirm this PDF? This PDF from gamma distribution? Is it same? Sama ke?
Sama sih.
Right. So when a gamma distribution is said to have a chi-square distribution when beta is equal to 2 and alpha is equal to v over 2. Right? So this is chi-square with n degree of freedom, v degree of freedom. So f x is having 1 over gamma alpha v over 2 and 2 over v over 2 x v over 2 minus 1 exponential negative x over 2. Right, so if chi-square with 2 degree of freedom, so this is alpha is our degree of freedom kan? Degree of freedom. So v over 2 here is equal to 4, right? V 4 divided by 2 is equal to 2. So the final one it should be gamma 2 with 2 power of 2 x power of 2 minus 1 is equal to 1 exponential negative x over 2. So should be equal to x exponential negative x over 2 divided by gamma 2 4 lah, 4 gamma 2. So this is the PDF where x is more than 0. Right? So this is a PDF for example number 13. Chi-square equal with 4 degree of freedom. And we need to show that the expected value of x is equal to 4. Right? To prove that this one is having chi-square with 4 degree of freedom, expected of x is equal to integration from 0 to infinity, right? So x multiply with fx multiply with respect to x lah. So this one should be integrated from 0 to infinity, x multiply with x should be x square lah, huh? X square exponential negative x over 2 for it's not square root, this is a gamma 2 with respect to x. So this one since we have 2x here, right, you need to do integration by part. So you need to show the integration by part procedure one by one, and its last answer should be equal to 4 lah. So you can do it by yourself lah. Dia ada banyak procedure, panjang sikit lah. I don't want to, I skip this one, this part. But you need to show, and then the last answer should be 4 lah. Kalau in final exam you just leave it like this, you will not get any marks, right? Because they ask you to show, so you need to show the procedure of integrating this, right? So it's equal to 4. Okay. So now example number 14. Let x, y, z be independent normal distributed random variable with mean equal to 0 and variance equal to 1. Determine C with an appropriate sampling distribution is given. Random variable C chi squared, it's not chi squared, this is x squared divided by x square, square root of x squared plus y squared. So we know that from here we have X, Y, and Z. All of these having a normal distribution with mean equal to 0 and variance equal to 1. This is the initial information that we have. Okay, so we need to determine C. What is the value of C? And then we know from a theorem number 2, x square means that standard normal distribution square is having a chi squared with 1 degree of freedom. And the summation of zi, right, ataupun x square, right, xi square means that the summation of normal distribution square is having, ataupun kita boleh kata summation of a chi squared, right, with 1 degree of freedom, 1 I equal to 1 until n is equal to chi square with n degree of freedom. Misalnya dia tambah lah degree of freedom tu tambah kan. You understand equation number 2, right? So from here we know that x squared is having a chi squared with 1 degree of freedom, y squared is having a chi squared with 1 degree of freedom, right? So from here we know C chi squared with 1 degree of freedom, right, and square root of chi squared with 2 degree of freedom, right? So C, suppose kalau kita compare with theorem number 4, I think theorem number 4, is it theorem number 4? Theorem number 6, sorry. If you compare with theorem number 6, we are trying to differentiate, divide between 2 chi squared, kan? So dividing 2 chi squared, we're going to have a F distribution, right? Maybe F distribution. So this one should be chi squared with 1 degree of freedom over 1, right? Divided by square root chi squared with 2 degree of freedom over square root of C. Kalau kita nak bagi sama, kan? Kalau nak bagi sama dengan F distribution, right? F distribution, right? Contoh-contoh macam ni, kan? So dia akan dapat macam ni lah, over 2, right? So this is having a F distribution 1 and 2, right? So bentuk lebih kurang sama, right? Let's say a square root of chi squared. So kita tengok theorem, where is it? Wait, I think theorem number 6 or theorem number 4. But it cannot be theorem number 4 because x square dekat situ, kan? Yup. We just refer to theorem number 6. So by this one, kita boleh tengok dekat sini, it's supposed to leads macam ni lah. Mesti ada square root dekat sini jugalah, right? So this one I think dia kena ada square root dekat sini. This is the question, kan? I tertinggal aku rasa, I think. Square root of x square divided by square root of x plus y lah. So this one should be f with 1 and 2 degree of freedom. So c should be square root of c is equal to 2. C supposed to be dekat sini lah, right? Kalau kita suppose dia cover semua ni kan, so dia supposed to kat bawah ni lah, so supposed to be C supposed to be square root of 2 lah. Okay, boleh. So now let's move to central limit theorem. I think banyak tak central limit theorem ni? I think banyak jugalah. So kita holiday on 1st until 7 until 8, right? So we will meet again on 10 May and 12 May. So I think central limit theorem we will continue on 10 May, right? And 12 May kita akan buat revision sikit. 13 we're going to have assessment number 1. 13, remember we have assessment number 1. So I think we stop here. We continue after our special break, right? So special break lepas special break kita akan tengok theorem central limit theorem lah. Okay, I think that's all. Thank you very much. Assalamualaikum.